Okay. So okay. So in last hour we get into this concept that if we want to predict something, we need to build a model, right? And when we are building model, we need to think about like two things. It's actually modeling is a balance, is a trade-off between two things. The first thing is specificity, right? We want our model to fit with our data, right? The closer the better. Right? That is one thing, right? You you don't want to have your model to deviate from your data. That is the thing. But the other thing is that your model cannot be too specific to the data, right? If you if you build a model that is exactly the same as your data, then you will not have that generality, right? To generalize the model, to use the model for future or for out of sample inference. Okay, so that's the thing. So when we use the histogram to model to model the distribution of a variable, okay, when we use histogram to model the distribution of a variable, right? We are doing that, right? So the problem still comes with us that if we are doing too complicated, right? It would be too specific, right? For example, that these things they are too specific to the data, right? So it will actually distort your generality, right? But if I'm doing like this, well, it will be too rough, right? Some information would be like just get lost, isn't it, right? So actually, the best practice is to is something like here, right? When there is no glitches like this, and it still remains most of the information. So this could be a good model, right? This could be a good histogram model that can use to do prediction, right? Okay. So actually, you can actually turn on the CDF of the histogram, okay? Just like, the histogram is actually a PDF, right? So as I told you that if I want to do the probability prediction, the better way is to do a CDF, right? So if you do a CDF of a histogram, you'll see something like this, okay? And you will see that this thing is actually not reasonable, isn't it? Right? This is what we call quantized error, right? Because histogram is actually a quantized model, right? It's quantized model. It actually like within each bin, like assume equal probability, right? Within each bin. So you will have like, because of this model form, the CDF would kind of have the jumps between the CDF, right? And that is actually undesirable, okay? So that is the problem of the histogram as a model, right? So as a solution, so nowadays actually we prefer to use this is called smooth density function, okay? Well, in R, they are all the same, right? They are tools to make histogram. They are tools to make smooth density function, okay? So just give it the data, and you call a function, and then you will get the density function, okay? So it's exactly the same like you are building a histogram. But the benefit of doing this smooth density function is that it no longer has this it no longer has this quantized error, right? Okay, but it's still subject to the complexity. If I if I if I do the bandwidth too large, then you can see that the it's smooth. It's more smooth, but it's less specific, right? Still there are the trade-off between the specificity and the generality, right? And this is too general, right? It will not capture the enough of information out of the data. And if I do it the other way, okay, well, this could be too specific, right? Isn't it? Right? So basically something like 0.5, 0.6. This could be a good case, right? But actually, when you are doing this model, you don't need to worry about the bandwidth by yourself. Actually, in the R tool, there's by default there's a algorithm to help you do that, right? Okay, I just want to take this chance explain to you that the model building process is actually like, first of all, you need to choose the model form, okay? As we can see here, you can choose among data rock, you can choose histogram, or you can choose the density function, okay? So I would like to let you know that data is the same, but you can have like virtually infinite method to build a model, right? Okay, so to build a model, first of all, you need to choose a form, right? Okay, and usually to model the distribution of a numeric variable, we'll choose like this smooth density function, okay? And actually, the tool will help you pick up a best. You know, there are some algorithms to help you determine the bandwidth, right? Okay. So suppose the bandwidth is 0.5, then you will have the like for this data, you will have a smooth function like this, right? So this we can use this smooth function, right, to help us predict the probability of next event, right? Okay. Now, okay, so suppose that we want to use this density function with 0.5 bandwidth to predict the probability of next eruption. Okay, what can we do? The first thing we need to do is to do a CDF, right? We need to turn this PDF into CDF. So it's easier to do the probability estimation, isn't it? Right? Okay. So actually, this tool is like totally interactive, right? It's built in R, okay, and this form is actually like totally interactive. Okay, so we let's do some exercise, okay? So you can like actually check this density function, and you check the density function. Check the CDF of the density function. Okay. Remember to set. Remember this to set the bandwidth at 0.5. Okay, to 0.5. All right. So now, if I want to see what is this? The 17.8, what is that? Is the probability of what? This is CDF, right? Okay. So the 0179, what is 0179? From 2 minutes?
From 0 to 2.
Yeah, from 0 to 2 minutes, right? From the left tail up to 2 minutes. So So if I want to know so you can adjust this, right? So can we let's give out some gifts, okay? So so can you calculate the probability that the next eruption time would occur for less than 3 minutes? What is the probability that the next eruption is less than or equal to 3 minutes? What is that? What is the probability?
34.1%.
How to do that? How you do that?
Change
The
to 3.
3, okay? And what is its point? To the right. Okay. Okay. So, see, that's the way to do the to use the CDF and PDF to estimate probability. Okay. It's quite easy, right? In CDF, in PDF you need to do the integration to determine the area under this yellow line, but integration is too difficult, right? So we do the CDF first, and then we simply use this number to minus this number, right? Okay. So what is the probability that the next eruption would occur between 3 minutes to 4 minutes? No, not that you, the other one. I mean, anyone else? How much? Raise your hand. 51? 51%? That high? I mean, between 3 minutes to 4 minutes, right?
16.
Sorry? It's 16%, right? 16%. Okay. Okay. So you know how to use this simulator, right? But now think you need to be careful though. If I change the bandwidth, the estimation will be different, right? Okay. For example, if I change the bandwidth to see that would be different. So so let's fix it at 0.5 for easier discussion. Okay. So up to this point, what have we done? Okay. We see the data, right? We see the chart, and we learn that using chart is good to see the structural phenomenon, but you cannot do numeric estimation. Okay. To do that, you need to do model. And we learned that the same data can build different type of model. Okay. And so the first thing to build a model is to choose a model form. Okay. And after you choose model form, you need to determine the model complexity, right? To balance the specificity and generality. And usually, this part is done by the tool. Okay. So you don't need to do the adjustment by yourself, right? Okay. But you need to know that. You need to know that the model that you build cannot be too specific, right? Otherwise, you will lose the generality for prediction. Okay. Okay. So you have a model. Basically, it's just use of tool, right? You put the data in and you call a function. Exactly the same way like you do the PCA, like you do the clustering, right? You call a function, and then the function will return the object, right? Model to you, right? Then you can use this model to do prediction, right? Okay. I just make it simple, but build a tool for you, right? So up to this point, do you have any question? Problem?
The time period is start from 1 point.
Sorry?
The time period 1.4.
Well, I just choose it like
Um,
arbitrarily. It's like, of course they will happen. As you can see, that the lowest one is here, right? Okay, so I just choose it that way. You can, well, theoretically it should start from 0, right? Right? Theoretically it should start from 0, but if I did it that way, it would be a lot of space here, right? You know what I mean? If I choose to start from 0, there will be a very long tail here. I just to make it look better. Any other question? No question. Okay. So the next thing is how is it? So what is this eruption data do with business? So we do a model, right? So we are talking about business analytics. So how is this data related to business? Can you figure out a scenario that the time of eruption that have an impact to some business? Can you think of that? See the thing, the first thing, and maybe the most important thing for business analyst is to that giving you a data, and you need to like figure out in what scenario this data is useful in business, right? Okay, so given this data, in what scenario it would be important for business? What kind of company can use this type of data? For what? Right? That is the things that a business analyst always has to ask yourself, right? Okay. So let's go to the next page. Okay. So if you ran a tourist helicopter company in Yellowstone, right? That thing would be important to you, right? If you run a tourist helicopter, so you have a helicopter flying on, right? So if you want to give your customer a good experience, it's better that when you fly to the old festival, it's still erupting, right? Otherwise, you will have to like, let's look at the data. If you do not have a good prediction, you can wait for like 80 minutes before you see the eruption, right? It's gonna like waste a lot of fuel, and your customer will feel very boring, right? Isn't it, right? Or maybe you run a popcorn store, a popcorn stand, besides the old festival, and you want to have your popcorn start popping, and like when the fountains is erupting, right? Well, that experience is a very, very good experience, right? Because the popcorn that I'm eating is actually like synchronized with the geyser, isn't it? Right? Today we are saying that this material things is no longer important, right? Because most of the material demand has already been satisfied. So this type of experiential value become more and more important, isn't it? Right? So now, if you ran this tourist helicopter company, so the prediction is important to you, okay? So the next exercise is that I want you to do that. I want you to use the density model of bandwidth equal to 0.5, okay? And I try to simplify the business scenario, so it's easier for you. Okay, we simplify your business scenario. Right? We simplify your business scenario so that it's like a game, right? So you can bet a $30 on a consecutive period of 60 seconds. Okay, you can bet on every consecutive 60 seconds. Okay, the cost is $30. Okay, and you will win 100 if the next eruption fall within the period that you're choosing. You get my point? Okay, choose 60 seconds consecutively, and if the next eruption occur in the period, you will get 100. Okay, if you choose the 60 second, you need to pay me like $30. Okay, and if that eruption does not fall within the range that you choose, you will lose 30. Okay, and if that things happen in the period you choose, you will win 70 or net. Okay, so I want you to use the simulator, right, to answer these 3 questions as a team exercise. Okay, when you finish, raise your hand. Okay, do you want to join the game at all? I mean, is it good to join the game? Second, if you join the game, which period should you choose? I mean, the consecutively 60 seconds, right? And the third thing is given the period that you choose, what is the expected value of the game? Right? There's an expected outcome, right? Expected value of the net outcome of the game. Let me say it again. The expected value, right, of the outcome of the game. Okay, what is that? Okay, the net. Okay. So, as a team exercise, I'll give you like a few minutes so you can discuss. Use the tool. You don't need to write program, right? Make sure you set the bandwidth to 0.5 and use the tool to help you do the calculation. And when you are ready, you just raise your hand, okay? Yeah. Hello. Wait. Hey, 我在上课。 好好好。
我问你，等一下那个小组的活动完，你有要让他们发奖品吗？
好。
等一下那个小组的活动结束完，你有要发奖品吗？
要啊，要不没有奖品的吗？
叫他上去买。
哦，没。应该还有，对不对？应该还有，没关系啊。等下小
饼干可以
就拿下来，
哦好。
看还剩多少，没有再去。
要我跟你去哪？啊，你跟我去哪？
Hi. Okay, have you finished your work? Any team is ready to present your decision? Yeah. Anyone figure it out yet?
Maybe just random it. Yeah, look at the car. Is it the right way? I'm not sure. What about this we need to do?
No, we need to set this one at this time.
Okay. You ready to say your answer? So do you want to play the game?
Yes.
Yes. Okay. This is team 3, team 2. Okay. Okay. You want to play the game. So what is the 60 second that you choose?
3.9 to
3.9
4.9.
to 4.9.
Yeah.
Okay. So what is the expected
Value.
what is the expected value of your net payoff? Yeah.
$47.7.
Sorry? $47.7? Is that right?
This multiplied with the 100.
Yeah.
Yeah.
You will have this probability
Yeah.
that you will win.
So it's higher than the cost that I invest. The
Yeah.
cost
But how about your cost?
is 30.
Yeah.
Also, it's
So what is your net? What is the expected value of your net payoff? 17.7, right? Isn't it? Isn't it? Anyone has a better expected value? I think this is already the highest, because the key is to find the 60 second that has the highest probability, right? So and because that, if you want to do it, you already have to pay $30, right? So if you choose in this period, there is 47.7 possibility that you will win 100, right? So the expect value is like 100 times 47.7 minus 30, right? That is the net expected value, right? That is the net expected value of the game, right? Isn't it, right? Now we connect everything together, right? Like from model to prediction, from decision, from prediction to decision, right? Usually that is the way. Now, is it easy to find this thing? It's not that easy, isn't it? Right? Yeah. Of course, you can like tune it this way, right? But you need to go through every period before you can like make sure that this is the best, right? Okay. But in the R environment, right, it's actually much easier, right? You can write a small simulation program, right, to scan through all of the possible strategy, right? Okay, so you can write a small program to scan through all of the strategy. Then you can like just make a very easy prediction. That's why we want to do. That's why we always need to learn programming in a business analytic course, right? So in this course, our job is not to teach you how to build model, right? How to build model is like the statistic course will teach you, okay? The other course will teach you, but we would like to teach you that with that model, how can you use the model to make good decision? That is the point that we would like to focus on in this course, right? Okay. So let's think about another scenario. Now the game rule changed. Okay. Now instead of choosing a consecutive 60 second, you can bet $5 on every 10-second period. Okay. For example, 0 to 10, 10 to 20, things like that. 10, actually the cost is the same, right? Because originally it's like 60 seconds and 30, right? Now it's like 10 seconds but 5. Okay. The difference is that now you can bet on multiple 5. You can place multiple bet. Okay. So this is more complicated, right? So for the maximum expected value, how would you place a bet? Now the strategy is more difficult, right? It's no longer just choose one single period, right? You can bet on every 10-second period, okay? Starting from 0. Okay. So it become a multiple choice problem, right? Okay. So if you want to answer this question by doing this, it will be like impossible, right? Right? So you need to use some programming technique to solve this problem, right? Isn't it? Okay. Let me see the time. We may not have time to go through the entire thing. Let me get it started. And so let's get back to the RStudio. So if you download the material this week, you will have a folder called Intro Probability. Okay. And within this intro probability, there's RMD called ENFEST2AX. Okay. This ENFEST2 RMD is actually the app. Okay. So if you click on this EN FAST2 RMD, you can actually run the document, and that will bring up the app. Okay. Okay. But we don't want to do that. Okay. If you run this EN FAST2 that RMD, it should bring up the app. Okay. But we don't want to do that. We want to do it in a notebook, so it's easier, right? So this FAST2AX RMD, this is the one that we want to do. So you can actually bring up the HTML. You got it, right? So this is the old FAST4. And, well, the first half of the code, I think you don't need to like go through it. It's just to teach you how to make the graph, okay? And as you can see, it's nothing complicated, but in order to do everything interactively, you don't really need to write a very lengthy code, right? Okay, as long as you can, you know how to do it. It's like not too difficult. But this is not our not our purpose. Okay. So far we already put the PDF in this object. Okay. So see, actually the PDF is generated in this way. Okay. So and in order to estimate the probability of the PDF, we can do this, right? So you simply like call this function integrate, and PDF is the PDF that we already built for you. Okay, so you don't need to build it by yourself. And then you can extract the value, right? For example, x1 and x2. You choose x1 and x2, and then you will tell you the probability that next eruption time fall within x1 and x2. Okay, so we can do some strategic planning, right? Okay. This is the code actually for the first exercise that we have just done, right? So let's see how I do that. See, I define a vector called x1, right? It's from 0 to 5. And I jump, every step is 0.1. So this thing is like, let me do that for you. As I told you, right, the best way to start from the middle of a notebook is to press this button. Let me say it again. The best way to start from the middle of a notebook is to press this button. I mean, 3 buttons here, right? Press the middle one. And it's gonna run everything above, okay? Up to this point. So, now if you only want to run a line of code, you just press the cursor on the line and press Control Enter, okay? So then you have this x1, right? x1, what is x1? Now this is x1. Because I'm asking for a sequence starting from 0 to 5, and every step is 0.1, right? So it's 0.1, 0.2, up to 4.8, 4.4, 5.0, right? So this is the starting point, right? And I actually for every starting point I plus 1, because we are choosing a 60-second period, right? 60 seconds is actually 1 minute, right? Okay, so this is the starting point, this is the end point, and then I actually use this function to calculate the probability, okay? That fall within x and x plus 1. Now, you still remember how S-apply works? Can anyone explain how this works? How this S-apply works? S apply is like L apply, right? I mean, it's for iteration, right? Isn't it? So usually this thing is a vector or a list, right? And S apply will apply the function to every element on x1, okay? And this is x1, right? Let me say it again. S apply and L apply is going to apply a function to each element of an object, okay? So x1 is a vector, right? So for every element in x1, it will apply this function, which means that for every starting point from 0 to 5, it's gonna estimate the probability, right, of the 60 second period, right? So within P, after I execute this, I basically have the probability, right, from 0 to, right? So I make a data frame, okay, and after I do the data frame, I should see something like this, right? This is the starting point and stop point and probability, right? Okay. Because start is x1, stop is 1 plus x1, right? And P is the probability, right? And then I do a top n1, right? Because I want to know the largest probability. So the largest probability occur at 3.9 to 4.9, and the probability is 47.66, right? You saw 40.7 because it round up 1 digit, okay? Still remember that? When you do this, you see 47.7, right? Because it just round up 1 digit, okay? Okay? So this is the way to solve the first problem, like using program, right? It's a lot easier than you do the simulation. The simulation has a lot of fun, but in order to do a smarter, more complicated business decision, you need to do programming. So the game rule changed, right? Okay, so game rule changed. So I changed the program because right now the way I can place the bet is no longer on the is no longer a starting point and at 1 minute, right? I can actually bet on every 10 seconds, right? So every 10 seconds is like from 1 to 10, and I have to jump 1/6, right? Because the unit of Russian time is minute, right? So for 10 seconds, I need to use like 1/6 of a minute, right? 1/6 of a minute is 10 seconds, right? So again, I do the things, and I pick up the bet. Okay. This is the bet that you need to place. If you want to have the largest payoff, then everything has a positive payoff. You need to bet on it, right? You see that? I basically make a data frame called DF. And this DF is things like, this is the start time, stop time, start time, stop time, okay? Right? And then this is the probability. And this is the net payoff, right? So if the net payoff, the net expected payoff, if the net expected payoff is minus, it is negative, you don't want to bet on it, right? So the decision is easy, right? Whatever the net expected payoff is negative, don't choose it, right? And whatever is the net expected payoff is positive, you choose it, right? So at the end of the program, I just make a filter that the net expected payoff larger than 0, right? Okay, so so this is the, if I want to have the largest payoff, right? This is the period that I should place a bet on, okay? As you can see that I press the bet from 1.66 to 2.167, right? So this is the chunk. And then I press the bet from 3.8 to 4.8. It's just choosing the you just choose the 10-second period that has the large enough density, right? Isn't it? But if I try to make the decision on the graph, I cannot do that, right? I need to do the decision on a code. And the code, as you can see, is not that difficult, okay? It's not that difficult. So, actually, I do not have, it's 12 o'clock already. Since we just run the midterm, right? So I don't really have a assignment for you this week, okay? So, but I do want you to follow this notebook, okay? There's an even more complicated case, okay, in case 3, okay? So next week we'll start from this point, okay? We'll start from this point. And I would expect that you have some understanding about the code, right? The code is a little bit more complicated, but it would bring you into a even more realistic business scenario, okay? This type of business scenario is still too easy, right? Usually the decision that you are making would involve more than one objective, okay? Let me say it again. Usually the business decision that you are making, that you need to make, would involve more than one objective, okay? And that is the difficulty of business analytics. I already have the thing and actually the code right up here, right? So you do not have any assignment this week, but try to follow the notebook and get some idea about the code, okay? We will send out some gift at the beginning of next week, okay? By asking you a question about this code, okay? And there's no assignment that you need to turn in, okay? Okay, so that's for this week, and I'll see you next week.